In Pakistan, miner workshops have melted down large scrap iron and used traditional casting methods to produce considerable industrial impellers. Today, let's see how Pakistan's ever-evolving industrial manufacturing achieves the self-production of oil pump impellers. Given the large size of these oil pump impellers, traditional sand molds can't be used. To mold the wooden replica of the impeller, the master craftsman first measures the overall size of the sandpit to ensure the impeller fits at the bottom. While adjusting the shape with a hoe, the master fills the special-shaped holes at the bottom of the impeller with oil-mixed sand to ensure the blades are correctly replicated. To prevent any voids in the sand, it needs to be manually compacted and tamped down, ensuring smooth casting later. Once everything is confirmed, the wooden impeller is placed at the bottom of the sandpit. Despite the wooden mold being full of holes, it doesn't affect the molding in the sand. The master centers the wooden impeller in the sandpit and refills and compacts the sand, making the inner wall smooth. After leveling the surface, they use a pulley system to lift the wooden impeller. Although the wooden mold matches the final product in size, it's much lighter. With the wooden base successfully removed, the impeller mold is complete. Since the inner side of the blades can't be machined with a lathe, the master craftsman creates core molds using sandboxes placed at the bottom of the sandpit. These cores create the space for the molten iron. After correctly positioning all the sand cores, the increased complexity makes manufacturing harder, resulting in a more refined product. With the internal crown slot prepared, the side with the blades is now fully molded. The other side is an utterly hollow concave, so it doesn't require iron filling, just plenty of sand cores to guide the molten iron. To ensure consistent width at both ends of the impeller, the mold must be elevated, preventing discrepancies in the final product. Iron pipes are used for positioning, and after pre-burying, sand is refilled to provide support, preventing core displacement from excessive iron weight. With the internal cores fixed, the edge cores are installed, allowing smooth casting of the concave surface. The surface is sealed with molding sand to avoid iron leakage through core cracks, ensuring airtightness. The large volume of molten iron needed generates immense heat, so a weight layer is placed on top of the mold to prevent the lid from lifting, maintaining the shape and ensuring safety. While molds are mass-produced, other craftsmen melt down the scrap iron, ensuring sufficient molten iron for casting. Since the workshop lacks advanced hoists and the impeller casting needs to be done in one go, the molten iron is divided into 2 casting buckets poured into the mold. Despite the time-consuming division process, the numerous workers complete the pouring in just 10 minutes. Although the gaps were sealed, some iron leaked due to the pressure. A second round of pouring is done to ensure success, leveling the iron with the mold's opening. After successful casting, a 24-hour cooling period allows the iron to solidify. Next, the edges are cleaned for easy hoisting. The iron blocks at the edges anchor the hoist hooks, lifting the formed impeller out of the sandpit. The high temperature has hardened the sand cores, requiring manual cleaning and removal of remaining scraps. Without advanced tools, the workers clean the surface in just 5 hours. The workshop lacks finishing capabilities, so the impeller is sent elsewhere for fine-tuning, completing the production of the oil pump impeller from scrap iron. What do you think of the craftsmanship of the Pakistani artisans?